Yeah, good morning to all of you. In this lecture, I am going to discuss the degree of freedom of our physical system. So, the first well-known system is a simple pendulum. Second, we will discuss about what is Atwoods machine, and third one is a spring mass system. So, in this video, I would like to discuss first what is simple pendulum. So, simple pendulum is a system, and its schematic is basically this is simple pendulum. So, simple pendulum is a physical system in which a bob of mass m, which is attached to a massless string of length L. So, this system is known as simple pendulum. It executes a simple harmonic motion. So, this is the property of this physical system. Now, this is the rest position, and this is the rest position, and this is displaced position. So we have to find out we will find out the degree of freedom this corresponding to this physical system. So degree of freedom is number of independent ways the particle can have motion, and mathematically it is defined as d degree of freedom. Simply d is simply 3n minus k. So what is our n? N is simply number of particles. So we have, this is our number of particle. So we have only one particle because a bob of mass m, which is attached to a massless string of length L. This system is known as simple pendulum. So number of particle in this system is simply 1. And what is k? Equation k is the number of equation of constants. So here n is simply 1. And what is k? K is a number of equation of constant used in the system. So what is equation? If this angle is theta, so initially this is rest position and this is the displaced position. And what is our interest? Our interest is to study the mechanics of this simple pendulum in displaced position. So this is displaced position, and let's say this angle is, this is L cos theta, and this is simply L sin theta, and this is xy coordinate, this is xy, and this is the reference system. So this is the reference system. So what is the relation between x and y? So x is simply L cos theta and y is simply L sin theta. So what is x square plus y square is basically L square. So this is one equation of constants, and our simple pendulum is in plane. This simple pendulum is in plane. It means it is in xy plane, or it is in xz plane, or it is in yz plane. So in this case it is in xy plane. It means there is no z coordinates. So if there is no z coordinate, it means there is one more equation of constants corresponding to z axis. So we have z equal to 0 because our pendula is in plane. So and we have to find out the degree of freedom of this simple pendulum in plane. So we have two equation of constants. One is x square plus y square is equal to L square, and there is z equal to 0. There is another way to define the equation of constant, because there is a relation between x and theta. So this angle, let's say this angle is, this is the arc. So what is your arc? This, and this length is this one. So arc upon radius, and radius is L. Radius in this case is L. So angle equal to arc upon radius. So what is angle? Theta is arc, arc is x, and radius is simply L. So x equal to L theta. So this is another way to find out the relation between x and theta. So this is also equation of constants. So you can express your equation of constants either in this term or in this term. So we have two different equation of constant corresponding to this physical system. One is x equal to L theta or x square plus y square is equal to L square, and another is z equal to 0 because our pendulum is in plane. So value of k is in this case is 2. So what is degree of freedom? Simply 3 into 1 minus 2, which is simply 1. So there are only one independent way through which our pendulum can have motion, or our pendulum oscillates, because in principle we can see that this motion is in plane, but it is restricted by which equation? Either this equation x square plus y square equal to L square, or x equal to L theta. So x minus L theta is equal to 0. See, so we have x minus L theta is equal to 0, and there is z equal to 0. This is known as equation of constraints. Equation of constraint, and which is known as k, and k is the number of equation of constants. K is 2 because we have two equation of constants in this pendulum, and z equal to 0. So equation of constants is very important parameter. Once we recognize the equation of constants corresponding to any physical system, so we can easily find out the degree of freedom, because in most of the cases number of particle is fixed. In this case it is 1. So we have equation of constant is 2 in this way. So degree of freedom is 1. So degree of freedom of simple pendulum in plane is 1. So this is the way to find out the degree of freedom of a simple pendulum. We have another very important example physical system, that is Atwoods machine. Next is Atwoods machine. So we have second example. Atwoods machine. So you should know first, before evaluating or before going to the exact formula of degree of freedom, we should know what is Atwoods machine. So Atwoods machine is a system, or its schematic is shown in, let's say this is mass m1, this is mass m2, and this distance is y, and this distance is L minus y. So this physical system is known as Atwoods machine, in which Atwoods machine is a system in which two masses attached to a pulley, by a massless string of length L. So Atwoods machine is a system in which two masses M1, M2, and attached to a pulley via massless string of length L. So this physical system is known as Atwoods machine. So this physical system is known as, and now how to find out the degree of freedom? Again we have degree of freedom is simply 3n minus k. What is n? N is a number of particle. In this case we have two mass, so number of particle is 2. And what is k? K is the number of equation of constants used in this system. So we have to find out number of equation of constants. So Atwoods machine in plane, this motion is in plane. If you will pull this is let's say it's coordinate. Let me write the coordinate. This is x, y and z. This is again x, y and z, and this x, y and z. So this motion is in vertical direction. This motion is in vertical direction. So vertical direction is y direction. This vertical direction is y direction. So what is the equation of constants? In this case, this from figure we can analyze or we can understand that its motion is only in vertical direction. Which means it has motion in only in y direction. It has motion only in y direction. So what is the equation of constants? It means, so equation of constants in this case, constants are x1 equal to 0, z1 equal to 0 corresponding to this mass m1, and similarly x2 equal to 0 and z2 equal to 0 corresponding to this mass m2. So we have 4 constants here, and we have one more constant. What is length of the string? Length of the string, which is constant. So length of the string is L, which is constant. So length of this string is constant because this mass is having motion only in vertical direction. And what is the length of the string? This is, let's say this is x1, y1, z1. This is x2, y2 and z2. So x1, y1, z2. This is y1 and this is y2. Because the coordinate of this mass is x2, y2, z2, and coordinate of this mass is x1, y1, z1. So length of this string is constant. So we have 5 constants in this case. Mathematically we can find out, or we can see that there is 5 equation of constants. So value of k is, now k is the number of equation of constants. So value of k in this case is, n is 2 because 2 masses, and k is 5. So degree of freedom in this case is simply 3n minus k, which is 3 into 2 minus 5, which is 1. So degree of freedom of Atwoods machine is 1. So we can, this is mathematical way to find out the degree of freedom, and we can also analyze physically. We can also, in earlier case, our pendula is in plane. So its degree of freedom is 1 because in principle it is in plane. So it has at least 2 degree of freedom, but there is a hidden equation of constants, that is x equal to L theta, or x square plus y square is equal to L square in previous case. But here in this case physically we can see that this Atwoods machine having motion in vertical direction, only in one direction. So it has only one independent motion. That is why there is that is why this Atwoods machine has 1 degree of freedom. So physically we can see, and mathematically we can also find out the degree of freedom. So this is the equation of constants. It has 5 constants. 5 constants. 2 corresponding to this, 2 corresponding to this mass, because it is only moving in vertical, only one direction, and this direction is y. That is why x1 is 0 and z1 is 0. And length of the string is also constant. In this system, length of the string is also constant. So that is why we have one more additional constant. So total number of constants is 5. Number of particle is 2. So 3n minus k, 3 into 2 minus 5, which is equal to 1. So it's all about the degree of freedom corresponding to this Atwoods machine. Thank you.